All right. As I was preparing for going into school tomorrow and preparing the next, or I guess actually the last round of packets that I'll be handing out to everybody, I thought that I would go ahead and make the video. Um, and I was just going to do a video on comparing and contrasting and looking at all the different systems and how they work together. But I was looking at the test and I realized, holy cow, there are quite a few questions about unicellular versus multicellular organisms. Now, I know that we went over this at the beginning of the year. It was on, I believe, the first benchmark. And I know that the notes are at least here, but I do want to go over unicellular versus multicellular one more time so that at least I feel comfortable that I have given you the knowledge that you need for the test. Remember, on this test, you are allowed to use your notes. If you are taking notes now, you probably won't miss the first 7 or 8 questions, which are on multicellular and unicellular organisms. If you decide not to do that, well, you may miss some. But let's talk about this. Multicelled organisms have specialized cells. Now, this is key right here. If you see anything about specialization or specialized cells, and you just learned about everything in the body, well, not everything, but a lot of things in the body. And you learned about nerve cells and bone cells and muscle cells and digestive cells and the heart cells and skeletal cells. You learned about everything in the body, and all of those cells have very special things that they do, and they all work together to make a multicellular organism function. Single-celled organisms are very different. They do all of life in one cell. Okay, some of them are long and skinny, some of them are round, some of them are like amoebas and they're a blob-like, so they don't have a very specific shape. There are some single-celled organisms that are plants. We talked about phytoplankton really early in the year, and so if you have a single-celled organism, a plant, sure, it can make its own food, but when you're talking about some of these other single-celled organisms, like maybe an amoeba, it cannot make its own food. It has to ingest food. And I think we watched a video of a paramecium eating and pooping, and then we watched a rhino eat and poop, and I remember doing that in class. So not all unicellular organisms can make their own food. They can move. Some of them don't move as well as others. But the big thing about unicellular organisms, as you can see right here, is they perform all of the life functions inside of one cell. So looking at this, if you were trying to decide if an organism was unicellular or if it was multicellular, there's quite a few things that you could look at. One thing, you could look at how many types of cells are there. If there's multiple types of cells, then you're looking at a multicellular organism. If there's only one cell, and there could be a bunch of unicellular organisms like in a drop of pond water, but if there's just one cell, if you're looking at how many types of cells and you can tell that there's only one cell, that's unicellular. If you were looking inside of our body, you would see all sorts of different types of cells, and you would know that we are multicellular. And that's something that's very, very important to think about. Single-celled, unicellular, and multicellular organisms, they have some things in common. Both of them need energy to survive. They're not able to make their own energy unless they're a plant. But if you want to put them as a whole, plants, yes, they make their own energy using the sun, but they all need energy. Unicellular organisms and multicellular organisms, they both reproduce. However, the one thing that a unicellular organism cannot do that a multicellular organism can do, at least inside some of them, is specialize. There are no specialized cells in a unicellular organism. You're not going to find cardiac muscle. You're not going to find skeletal muscle, nerves. You're not going to find all that. It's one cell. It does everything inside of that one cell. Now, unicellular organisms, I don't want to say they have it made because they don't. I'm very happy that I'm a multicellular organism. But the one thing that unicellular organisms don't need that we do, multicellular organisms, we need transport systems. And we talked about the transport system. The circulatory or the cardiovascular system is our transport system, and it moves oxygen and nutrients and blood around the body. That's extremely important for us, and unicellular organisms do not need that. If it weren't for our transport system, for us in particular, we wouldn't be able to exchange gases. That need of exchange of gas, of oxygen for the cells and getting rid of that carbon dioxide, we have to have that. And one of the ways that we do that is with our transport system. When we say unicellular, we know that it's typically made up of one cell. And as a general statement, I think it's safe to say that unicellular organisms are smaller than multicellular organisms. Typically, with a unicellular organism, you need a microscope to see it. We do not need microscopes to see people or elephants or even crickets, even getting smaller, the gnats that fly around bananas and apples that you have no idea how they even got in your house to begin with. Those are all multicellular organisms. We don't need microscopes to see them. Unicellular organisms, however, are one cell, and they are much smaller than multicellular organisms. So as we take a little closer look at unicellular, there are bacteria, amoebas, and most, not all, but most microscopic organisms are unicellular. Again, if you happen to have this, how do you know something's unicellular? Well, it's, as it says here, all in the name, unicellular. It's one cell. It performs all of life's functions inside of that one cell. Eating, respiration, breathing, getting rid of waste, movement, all of that inside of that one cell. They do have to obtain energy. They want to grow. They reproduce. The bad thing for unicellular organisms, like we talked about when we did them earlier in the year, any small injury pretty much means death for them. They don't have those specialized cells to help repair them. That is one cell. If it gets damaged, it's pretty much over if the damage is bad enough. We, however, can fall and scrape our hands and knees if we fall off a skateboard or a bike or something, and our body repairs itself. And that's a good thing that our body repairs itself. So that's unicellular organisms. Multicellular organisms, again, they're made up of many cells. If you see something talking about specializing, you know you're talking about multicellular organisms. You've learned a lot about specialized cells. You've learned a lot about things from muscle cells to skeletal cells to nervous system cells. You've learned about the cells that make up the heart. You know about all of this different specialized cells in the human body. And we are very complex because we're made up of so many cells. Whereas the unicellular organism is very, very simple, multicellular organisms are very, very complex. Multicellular organisms are very, very complex. We have so many different types of cells that make up our body, and it's extremely important that we know the difference between unicellular and multicellular. Between these slides, what we've talked about in these notes and the videos that are attached, I feel comfortable. There's only like 7 questions on the test. And again, you can look back at the slides, look back at your notes, take time to research it, anything like that. You could even ask a question if you need to in Google Classroom if you need some help on Friday when you're taking the test. I'll be online all day and I'll be there to help you out. Hopefully these notes help you out, and I'm going to stop this, upload it, and then we're going to do our how the body systems work together video right after this. I'll post both of those on tomorrow's video, and then we will move on.